So this next section of notes is just review basically the same section. So you'll recall that you've got if two powers with the same positive base other than 1 are equal if and only if the exponents are equal, and you recall B, if the base is greater than 0 and the base is not equal to 1, then b to the x is equal to b to the y if and only if x is equal to y. So we proceed with our basically algebra problems now using things raised to the power of x. So if it's multiplied by 2/3, divide by 2/3. If I divide by 2/3, it's the same as multiplying by 3/2. So you get 3/8 to the x is equal to 3 times 9 is 27. 256 times 2, 512. So hopefully you can recognize, right? Basically, you got to take the factors of 27 and the factors of 512. 27 is 3 and 9, which is 3 and 3. So 27 is 3 to the 3rd. 512, if it ends in a 2, it's divisible by 2. So 2 and 256. And then that's 2 and 256 divided by 2. It's 128. Right, and 128. There'll be a lot of 2s. 2 and 64. 2, 32. 2 and 16. 4 and 4. 2, 2, 2, and 2. So you got 1, 2, 3, 4, 5, 6, 7, 8, 9 2s. 2 to the 9th. Or, right, but that's not going to help us much. You also have 2 times 2 times 2 is 8. And how many batches of 3 do you have? There's 8. Right, there's 8. And there's 8. So 2 to the 9th. Basically, 2 to the 9th is same as 8 to the 3rd. So now that you have 3 8s to the 3rd, right, x must be equal to 3. And so that's the first example. Let's do this one. Times 2/3 divided by 2/3. If I divide by 2/3, it's the same as multiplying by 3/2. You get 1/2 to the x power is equal to 3 over 12, which is the same as 1 over 4. And 1 over 4 is really the same as 1/2 squared. So that makes x equal to 2. Let's see if we can do another example or two, and then we'll keep working on the homework for this section. These next examples, it's multiplied by 25 over 27, divide by 25 over 27. It's the same as multiplying by its reciprocal. Then 25 times 25, 625. So you have 3/5 x is now equal to 81 over 625. So let's see if we can figure out the prime factors of 81. Well, you already know it's 27 times 3. And this is 3 and 9, 3 and 3. So as far as 3's go, 1, 2, 3, 4, 81 is 3 to the 4th power. Now let's see if 625. All right, you got 5 and 125, 5 and 25, 5 and 5. 5 to the 4th power. So you get 3/5 to the 4th power, making x equal to 4. Last example, if it's times 2, divide by 2. If I divide by 2, it's the same as multiplying by 1/2. You get 4/13 to the x power is equal to 32, and 169 times 2 I think it's 338. Let's double check on our calculator. Yep. Okay, so let's find now the prime factors of 32. We've got 4 and 8, and that's not going to do it. This is 2 and 4, 2 and 2. Also 2 and 2. So we got 5 2's. No wonder this is working out. Not working out right. This technically simplifies to 16 over 169. Scratch that out. 16 is 4 and 4. Right? Also 2 and 2 and 2 and 2. But for this purposes, we're looking for a 4. You got 2 of them. So 4/13 to the x is equal to 4 squared. And 169 is 13 times 13. So 13 squared. So that makes x equal to 2. And now let's go to the homework packet. I lied. We're not going to the homework packet just yet, but we are skipping these examples. You have enough of those? we want to take a look at this Gene and Marco and see, well, who solved what correctly. So Gene reasons if it's multiplied by 9, we've got to divide by 9. And they do that by multiplying by 1/9. And they're right so far. So, and then is 729 divided by 9 81? It is. And what's the prime factors of 81? 3 and 27, which is 3 and 9, which is 3 and 3. So 81 is definitely 3 to the 4th. So x is 4. This is absolutely correct. How about this one, though? What did they do? They took 3 squared. No, this is where they made a mistake. If 2 plus x is equal to 6, right? If 2 plus x is equal to 6, x can't be 6. X has to be 4. So, technically, this combination here is not wrong. When they connected it, this being equal to that, that's where the error occurred. So, Gene is definitely correct.